All right, so we're going to get started. Thank you all for coming. My name is Rob Salguero-Gomez, and I am the tutorial fellow in biology at Pembroke. I have been with the college for 6 years, minus 4 years if you discount the pandemic. And it's really been a pleasure to be able to learn so much from so many colleagues and students, as you will be able to see in a second. And I think that you're in for a real treat. What we're hoping to do in a second is to showcase just the tip of the iceberg of things that Pembroke College, as a leading force in conservation biology, is doing within the four walls of the city and beyond. So with us, we have got three fantastic speakers, and I'm sorry, then you're stuck with me as the fourth one. Nick Hawes, Amy Dickman, and Francik. I'm going to ask them to start up one by one in a second and then briefly introduce themselves. So we'll start with you, Nick, if you don't mind.
Okay, that wasn't a very long second. Yeah, my name is Nick Hawes. I'm a professor of AI and robotics. So I work within the Department of Engineering Science. I'm an engineering fellow here. But my research is applying decision-making methods from artificial intelligence to robots. So you have robots out in the field deciding what to do, where to go, how to do it. And I've been applying those decision-making techniques to robots to monitor ecosystems and assess biodiversity.
Amy?
Cool. Hi, everyone. I'm Amy Dickman. I am a professor of wildlife conservation here, and I'm the director of the Wildlife Conservation Research Unit. I've worked for about 25 years in human-wildlife conflict, particularly large carnivores in Africa, and that's what we'll be talking about more today.
And that's what Barbara.
Hello, I'm Barbara Francik. I'm a student here at Pembroke. I've just finished my integrated master's in biology and focused on animal behaviour. And for the past 2 years, I've been leading the Pembroke Biodiversity Project, which I'm speaking about more today.
Excellent, thank you so much. And I am an associate professor in ecology at the Department of Biology. And I have been drastically altered by interactions that I have had with many fellows and students within this college. A few years ago, Amazon launched the first delivery of its packages with a drone. On the same year, a member of the royal family came all the way from Buckingham Palace to meet with Nick Hawes, Professor Nick Hawes, where they had a chance to interact with Betty, an autonomous robot that serves key functions in a controlled environment. By key functions, I mean giving coffee to academics. Against the backdrop of these drastic technologies, there's been two crises. The first one is a climatic one, global warming, and coupled with that one is been the loss of biodiversity. So what I want to pose today is that as an ecologist, I'm perfectly now capable and equipped with things as small as this thing, a drone, to be able to do what we used to do for a fraction of the money, a fraction of the time, and tenfold more accuracy for ecological monitoring.
Okay.
And this is really important. Monitoring ecosystems is really important because we're actually losing species at a much faster rate that we are understanding the ones that we know. Here you have got some examples of species that are currently under great threat of extinction. The late E.O. Wilson, one of the main forces behind ecological monitoring, stated in a recent publication that biodiversity needs more people in the field monitoring. And my realization through conversations with folks here at Pembroke has been that actually what I think we need is more wires, what I think we need is more rotors, what I think we need is more wheels. I'm the curator of the largest database of ecological monitoring of natural populations around the globe. It's called Compadre. If you speak Spanish, you will have a sense of what that means. If you don't, then learn this beautiful language that it is my mother tongue. Through Compadre, I've come to the conclusion that while we have done a fantastic job at monitoring natural populations of plants in green and animals in blue around the globe, this work is really tedious, is not efficient, and it has created geographic biases, specifically around the fringe of the tropical forest in arboreal ecosystems, both of which are at great risk of extinction. We lack information. And what we don't understand, we cannot manage. So the classical ways of monitoring populations of, say, plants or animals, and this is a very young Rob, first-year PhD back in the lower Jurassic, entails putting down permanent plots for sessile species like plants or tagging individuals that can move like rhinoceros, and then following them through time, which is time-consuming, obtaining information that then needs to be digitized about how they're responding to the environment, creating models, and then forecasting. We're pretty good at the last three steps. The bottleneck of ecological monitoring is here, data collection. So the photo I just showed you is one of 2005 when I started my PhD. And the video that I'm going to show you in a second is one of just a short few years ago, where one of my PhD students, Sarah Middleton, was collecting information to understand how climate change is affecting grasslands in White Woods, a forest that we own locally in Oxford.
The increase back to the species, like the target species.
No, it didn't work. I was trying to make it stop making noise. Yeah. Sorry.
And that looking at the effect of neighboring farms and see how that affects the growth and the survival. I record the different species, the different types of plants around flying a bit farm, and record their size and how many the farm using these acetate sheets. And
so what you can see there is poor Sarah Middleton working under the heat of the sun, long days, collecting information by hand. Tedious, error-prone, not efficient, expensive. It is actually expensive. And I would argue that the talented students should better be placed building models than collecting data that drones and robots could actually collect for us.
Measurements.
So that has then revolutionized the things that Pembroke are doing as a consequence of these conversations. Introducing Dr. Shruti Murthy, our Pembroke Smithsonian Junior Research Fellow, who's actually in presence. So one of the things that Shruti is doing is she's taking advantage of the latest and the greatest technologies. JEDI 2, one of the cutting-edge satellites that goes around the globe quite a few times during the day, collecting information that is helping her understand how lianas, some of which are actually invasive in tropical forests, are hindering the growth of natural tree species in the tropical forest. Again, in an area, in a region around the globe where we know the least and where we need the most. Introducing also another Pembroke affiliate. Jessie McLean is a recent graduate from the MBio program in the same cohort as Barbara. What she did is she also took advantage of satellite information to focus on the effects of fire. Fire is increasing both in terms of frequency and intensity in boreal forests, the other region of the globe where I told you we have very little data. What Jessie and I have done is to build models where using satellite information, we are tracking growth of different trees. We're tracking shrinkage or dieback as a consequence of fire. We're tracking mortality and new equipment. And this key information is now being used by the USDA and Canadian governments to help assess with what frequency can we actually allow the fires to happen for them to be compatible with the regeneration of the natural ecosystems.
No.
And then over to my esteemed colleague.
I thought you were going to say things about these.
Oh, you want to? I'm happy to.
It's up to you.
Yeah.
Oh, God. Right, okay. Cool. So the challenge really is how do you automate those data collection processes? So we've been looking, so I'm just going to reset my timer so I don't speak for too long. The challenge is to kind of automate the data collection. There's many, many parts to this. In general, the way we think about this is we want to place some kind of data collection pipeline on a mobile platform, a human as a mobile platform, and you can move that around a different location. And I'm going to give you a couple of examples of how we actually do this. And I'm going to use the first example I'm going to use is the raindrop experiment, which Rob has been leading up at White Woods. So White Woods is a couple of miles that way-ish. It's one, if not the oldest ecological site, survey site in the world. And this is the raindrop site where Rob and his team are simulating future climate change outcomes by using these different rain ant shelters. So they prevent some light getting in, prevent some water getting in, and the frames that stop some water redirect that to other locations. So it's a way of kind of creating these different outcomes. The video you saw of that student is measuring under these. They're measuring under these to actually look at the different species that exist, the different biodiversity changes under these interventions. So how can we replace the monitoring? Well, we've been looking at deploying an autonomous robot. So this is a robot called a Husky, mounted at the top of this pillar. You see a hyperspectral camera, or multispectral camera, and we can use those signals to assess biodiversity over time. So it's a lower fidelity sensor than a human, but actually with enough data, we can aggregate the different reflectances we get in different spectral bands to effectively count how many different types of species are present. The interesting robotics challenge is actually moving this thing around. So you've got a large scale plot, we've got 40 different locations, and we want as much data as efficiently as possible. So the way we do this, before I say that, this is an image from a hyperspectral camera. This one was mounted on a drone like the one Rob showed. but this is being flown by a human. You're a human, right? Yeah, okay. Tick box. So here you can see the kind of different reflectance patterns, different spectral signatures you get from different species, and that's how we're using this information to assess biodiversity. These cameras are expensive, and so you can't mount one on every frame, for example. You have to move them around. So we mapped the site, and a lot of these kind of monitoring problems, you typically start with a map that your robot can follow. This is the kind of human-constructed map that shows you this maze of routes that our robot can follow, as well as the locations. The robot's going to drive to these different dots and take images of the location with that hyperspectral camera. And this is the robot in action. So you can see at the top, I think that might give me a zoom. Up here, we've got both the hyperspectral camera, we've got a thermal camera and a natural camera. We've got a LiDAR up there, which we'd ultimately like to use to assess growth over time and things like that. And this robot drives around, parks by the end of the site and images the floor. And a lot of the robotics work here was done by my colleagues, Daniele and Matt. Daniele is also a stipendiary lecturer in engineering. So the robot moves around looking a bit like this. And this just really, there's not a lot of results to show because the data is feeding into pipelines that we're going to work on over time. We're going to apply machine learning techniques to the images to do some of the assessment. This just shows you the robot driving, which is cool. This is autonomous, so there's no human driving it, but it shows you some of the environmental challenges. Dealing with this grass has proven one of the biggest problems. Robots don't know about grass. They use range measurements, distance measurements, and if those distance measurements say something is at a short range, then the robot tries to not drive through it, because that thing at a short range might be a wall or a person. But when grass grows up in front of its cameras or its LiDARs, these robots aren't able to assess reliably what's in the way. So this just shows our robot monitoring and dealing confidently with the grass, which is excellent. This shows you a little bit about how the robot's doing that autonomous tracking. What we do is something called teach and repeat. So the robot was driven on this path, and when it was driven on this path, it remembered the images it saw. And then at the top left, it's trying to recreate those images. So it's matching features. So these orange dots are features. It's trying to say, effectively, can I see what I saw when I was driven here before? And if I can, then I kind of know where I am. And I try and drive along this line to maintain the alignment between the features that I saw previously and the features that I saw now. So this is how we're achieving autonomy. And the same technology is the kind of thing that's being deployed into autonomous vehicles. There's a local Oxford company called Oxa that are using this very same technology to drive their autonomous vehicles. So that's one example. I just want to give you two more examples in the last bit of time of just how we're kind of extending these ideas now to do further environmental monitoring of robots. So as Rob said, we need more data collection devices on the ground, and we also need better pipelines. So your slide had kind of more automation in the kind of back office as well. And so what I'm going to show you now is some work, again, done with colleagues in the Robotics Institute here, Morris and Matthias and Alex, but also inspired by work and some unsuccessful funding applications that Rob and I had about building a digital twin, so a digital model of White Wood. So this is forest land, and what we've been doing recently is deploying mobile robots into this forest land to measure count the number of trees and measure their growth. So this is a quadruped robot called an animal. It's got a LiDAR scanner at the top, and we can have this autonomously walking through the forests, building large-scale 3D maps that can be used to measure the growth of the trees. So very quick videos. This shows actually a handheld device, but this is the same thing that's on the robot, building a map of the trees. So this is the LiDAR scanner being moved through automatically, again using a type of artificial intelligence, segmenting and measuring the trees. That gives us an assessment of the growth. We can do this time and time again. And we can also build large-scale 3D models. So these models could be used for biodiversity assessment. They could also be used for sustainable forestry as well. So this shows you really just the starting point of these pipelines. And what we're working on at the moment is actually the kind of autonomous navigation. Working in forests is really, really difficult for the same reason that grass was difficult for the mobile robot. How that legged robot is able to autonomously move through that space is actually a very large challenge in the engineering department. A final example I want to give you, and here we're kind of moving out in scale each time, is work we're doing with the National Oceanography Centre. So at a very different scale, people are feeding in data from underwater robots called gliders into climate models. So here we're looking at robots that are deployed in the North Sea, so up here somewhere. These robots are measuring the temperature, salinity of the water. So this is an underwater glider. These gliders can exist in the ocean for months and months at a time. They bob under the water for a couple of hours, measuring the temperature and the salinity. They feed that data to the Met Office, and the Met Office use it to update their climate predictions. So this is a really
kind of automated process in the field, but every time that glider surfaces, there's a human, oh, that's my time, there's a human looking at a kind of Google Maps-like interface, rerouting the glider according to some very loose specification. What that human doesn't know is how good the predictions are down here. So what we've been doing in the last year is finding ways to automate discrepancies in the climate forecasts with routing plans for the gliders, and again using different types of AI to drive the gliders to locations in the ocean where there's a discrepancy between the climate predictions and the data we get in real time. So this is something we're deploying into the North Sea. I think probably September, this will go live on the gliders that are feeding into the Metops. This all comes from the initial conversation with Rob about the challenges that are present in ecology and biology and how we can address them with robotics. So I think that's us up. Thank you very much for listening. How are we doing? We can do questions at the end?
We'll do questions at the end. Okay, I'm going to do a smooth transition to the second presentation.
Yeah.
Also, you see one by 10 by
I can...
plus you for the text.
Okay, yeah.
Just like to say, Amy. That's fantastic.
Cool, fantastic.
Brave.
Nope, we'll go back.
That's not the first time.
Okay, okay, so, all right, everyone, thank you very much. That was great. I'm going to talk about something that feels like going back in time because there is not one robot in mind, but one of the great things about Pembroke is that it's really great to see and to understand more about these things so that we can really think about where these sorts of overlaps might be. And I think there really is a good potential for overlapping this very on-the-ground community-based work with the kinds of innovations we've just seen. So I'm going to be talking about community conservation, in particular in East Africa. And this seems far away, but actually there are links to Oxford. And because if you look around, something I do on board when I'm bored in an airport or train station, I sometimes look around and see where is the closest lion that I can spot. And within 5 minutes, I can always see a lion. And right here in Pembroke, we are surrounded by the 3 lions, Argent, whatever they call it. And it's really, this is symbolic because people have always treasured big cats for as long as humankind has existed. The very first figurative art that people carved out of woolly mammoth ivory about 40,000 years ago was the body of a human and the head of a lion. So right from the start, when people started to represent ourselves, we did it merged with these big cats. And yet similarly, if you look at cave art in Chauvet in France, you'll see extensive depictions of big cats. And that's persisted right the way to the present day. So everything from flags and heraldry to sports teams and luxury goods, there are big cats everywhere because we think they're beautiful and incredible and they symbolise strength and power. All the way down to 10 Downing Street, which was been, we'll see what happens with that in a week or so. And here back to Pembroke, you'll see it today if you're walking around with the lions on the crest used for the festival. But there's a big difference between us feeling those things and celebrating that stuff and the local realities of living with these animals. The local reality of living with species like lions is often this. So this person had 3 cows. He was saving one for his son's circumcision ceremony. That cow was killed by a lion. He then went out, poisoned the carcass, killed 3 lions. That is bad for him, bad for the lions, and bad for the cattle. So lots and lots of conflict that goes on. And that leads to very high levels of killing. We've actually had the highest recorded rate of lion killing anywhere in East Africa, in southern Tanzania where I work. This, for example, this is a lion we had with a radio collar on. We had a mortality signal showing that it was dead, so we went out to investigate. There were 6 dead lions, dead hyenas, jackals, and 75 critically endangered vultures. This sort of stuff decimates wildlife. It's a huge, huge threat. And so the threats that are driving lions in particular down, people don't realise how threatened lions actually are. We've done a very poor job of communicating that. They now only exist in under 10% of their historic range. There's only about probably just under 25,000 left of them. And that's mainly because of human-wild conflict and the loss of natural habitat and natural prey. And so here at Pembroke, I'm obviously based here, and I jointly run an organisation called Lion Landscapes with Dr. Elaine Cotterill. She also has her PhD from here at Oxford. And we are working on some of the most important lion landscapes left on the planet to try to understand the threats and resolve them. So we work in southern Tanzania in Rungweroha and in Saluniere. Work in central Kenya in Laikipia, where Pembroke has strong links through a partner. And then here we are working in the Loangwa Valley as well. So the most important thing when you're looking at sort of understanding and resolving conflict is having a critical foundation of that community trust and engagement. And that can be really, really hard. When we first moved into this area, there was huge amounts of lion killing, and everyone said, you've got to engage with the Barabeg. They're the ones killing this particular pastoralist tribe. We tried for 2 years. There was nothing. They would run away from us, zero engagement. At one point, I was surrounded in the bush in the middle of the night by warriors with spears up. I thought I was going to die, but I was like, these people genuinely do not want to engage. And we were told it will be impossible for you to engage with them. So we tried everything on the planet, and then, tech to the rescue, we happened to put up solar panels at camp to charge our laptops, and suddenly the Barabeg turned up to charge their mobile phones. And I was like, why didn't I think of that? So I mean, obviously, give them what they want, not what they don't want to come to a community meeting. They want to charge their phone. And beforehand, they were walking 20 kilometers to go and charge their phones. Now they've got a charging station. And they use them for the same things that everyone else uses them for, tracking livestock prices, saying if a child goes missing or livestock goes missing, sending funny memes on WhatsApp. Okay, so this was super important and got them to start talking with us, slowly, but it did take time. And we eventually got them to come up for a meeting at the camp. We said to them, we are not the police, we are not Wildlife Division. We are just trying to understand why you kill quite this many lions. And they said, fine, we're going to work with you. It was the best day for the project. Then those same young men went out and killed 7 lions right around camp. And this was the worst day for the project. And we were like, God. And I called up a friend of mine, Leela, who works in Kenya, and I said, I can't work with them anymore. I don't know what to do. And she said, you told them, this is a test, you've told them you care about them. They know you care about lions. They're putting it straight out. Which do you pick, the lions or them? And so you said, you've got to pick them. So we didn't do anything. We measured the carcasses. And sure enough, then they invited us down to their first sort of community meeting where they've ever had an outsider there, let alone a Westerner there. And they said, now we'll work with you. And since then, we've worked with them for over a decade. It's lots of ups and downs, but showing that we were willing to put community needs ahead of our own research and conservation needs was absolutely fundamental. So that led to them explaining there were 4 key reasons why they were killing so many lions. The first one, the thing you'd expect, a tax on livestock. And this is a huge cost for vulnerable households. This was costing people about 18% of their annual cash income. None of us are going to put up with that. The second was the people that got very few or no benefits from wildlife conservation. And the few benefits that were there were inequitably distributed. So the people living with most of the wildlife were not the ones getting most of the benefits. Those people were in the bigger sort of villages right by the park gates, for example. The third one was very important. It was a cultural issue. And this is why it was so important to get the warriors on board. And they explained to us that when you go out and you kill a lion, the bravest one, the one who throws the spear that first hits the lion, he's the one that gets to go and cut off the right front paw of the lion. And we'd found lots of dead lions missing a right front paw. We had no idea why. It turned out this was a sign that they'd been culturally killed. And they went around the village and they told people about the hunt, and they got gifts of cattle, and they got women to sleep with them. So the same things that drive human behavior the world over, money and sex, drive this kind of behavior as well. And the last was a lack of conservation awareness. People just didn't think that lions were threatened. It's like going into Trafalgar Square and telling people that pigeons are threatened. Why should they live with these? Why should they care about conservation? So thinking about all of these, we started working on reducing attacks. Now, 2/3 of attacks happen in poorly constructed livestock enclosures. So we started a program to reinforce them with why this is a cost-sharing basis. This looks rubbish, and it was meant to be like the first step. If you went into a zoo with a lion enclosure and that was it, you would leave and report them. But actually, they're like 95% effective at reducing attacks in the household. And we've just submitted a paper showing clearly, actually, that these also reduce attacks at neighbouring households too. We don't quite know the mechanisms, strong relationship, to show that this has a strong protective effect at protecting the stock. But you don't want to just leave them so that then in the morning the livestock comes out to slightly hungrier predators. So you've got to be able to protect grazing stock as well, and we place specialised livestock guarding dogs. The problem here is that people are very food insecure, and how do you end up feeding a dog that's that big and maintaining that if they can't feed their children, which is often the case, how are they going to feed a dog? There's lots of ethical issues that come into it as well. Then the main thing is providing community benefits, and this has to be driven by what the community want. And unsurprisingly, they decided they wanted an investment in education, healthcare, veterinary medicine as 3 key things. So we've twinned like 16 different schools where we provide equipment. We feed over 1,000 school children every day with nutritious porridge. We've just fed over 1 million meals to these school children. It makes a huge difference in children going to school and staying at school, and the attainment's gone up. A real focus on maternal and neonatal healthcare to make sure the women who are rewarding the warriors for killing are actually really invested in this, because these 2 were strong priorities for them, actually, I'm feeling. And then investing in veterinary medicine, because people had 9 times more livestock lost to disease than to depredation. But then what we were finding is that we did this for several years and people liked us and they waved at us as the cars went by and we felt pretty good. And still lots of lions were being killed and wildlife was being killed. Meanwhile, we were putting up camera traps and those were being stolen because people didn't feel invested. We were like, God, it's not going well. So we ended up thinking, of course, you need to make sure those benefits are strongly linked to wildlife. So then we handed the camera traps over to the communities, said you camera trap them, and you decide how many points each wild animal gets, and those points will translate into extra community benefits. It totally transformed it overnight. It took months to decide how many points each animal should get. I wanted a simple system, 1 to 5. I was outvoted. They wanted thousands of points per animal. Fine. So now a dick will get you 1,000 points. There are points, you get more points for more conflict-causing animals. A baboon or a berbers or any other primate will get you 1,500 points. Something like a lion will get you 15,000 points. It's per individual animal. A wild dog is the top individual spot, so that's 20,000 points. And because it's per animal, this spot gave them 340,000 points. They were thrilled. This gets you 0 points. But here's the picture you get wherever in the world you put young men camera traps of alcohol. If you could put one in Pembroke tonight, we'd get this photo.
That's Rob, isn't it?
And then 0 points for snared animals to reduce snaring, and extra points for highly traded animals like pangolins. Those points translate into additional community benefits. So we already do the baseline stuff, the school feeding and the healthcare, but this is extra, and this has really changed it. I remember community leaders standing up and saying that wildlife is now driving the development, whereas before it hindered it, wildlife is becoming the engine of them seeing real development. But it's really improving coexistence. We see people excited to see breeding lions on village land. When people see a wild dog den, they used to burn it out. They will put the cameras nearby so they get lots and lots of images of those wild dogs coming in and out every day. This pangolin, interestingly, was caught, one of the most highly traded mammals in the world, and they brought it in to sell in the village, and the villagers said, hang on, that one we get loads of points for. That's going back. And they were like, you could sell it for all sorts of money. No, we don't care. So there's a big argument between it. This is him on his way back to freedom, being released. And he got released back out there. It actually makes no economic sense, I have to say. They should have solved it. But the group, sort of what desire to have him there was really key. And they dragged him in front of the camera trap like 8 times. And then the cultural issues like money and status was, we thought, very hard to deal with. We could replace the money that people get because we could employ these young warriors as what we call lion defenders. It was very important to unpick what a warrior meant. So it means to be able to defend your community, to be brave, etc. And so we have them out there tracking lions. They chase lions away if they're near households. They are community responders, which they're meant to be. So they get the money for doing that. We said, how can we replace the status you get for killing a lion with a spear? It's hard to do that. And they said, there's only one thing that could replace that in terms of prestige, and that's learning to read or write, because no one can do that. So we taught them all to read or write. They're now learning English. They have a passport. They go to Kenya. And I remember these women coming to us and saying, we used to want our daughters to marry lion killers, but now we want them to marry lion defenders. And then the last was improving conservation awareness. And this isn't rocket science. We take people into the park so that they can see wildlife in a non-threatening way. We also do film nights out into the village. People come from miles around because they didn't get to see films. I think they want to see the latest, Mission Impossible, but we show them Living with Lions. They seem to like it. But the real problem here is that these films are in English. And even if you have someone standing there and translating, the very clear narrative is this film is not for you. And we've bitched to all the fun, Nat Geo, Disney, and all these people to say, these films are so amazing, and they inspire all of us, but the people they need to inspire are these people. And they need to be in their language, and it's got almost nowhere. So we end up thinking, well, how can we do that? So we ended up writing our own storybooks with these people and talking about putting them at the heart of the conservation story. And these have been huge. So these were free to all the local schools and families. These kids don't have books. And it's amazing for them to see themselves featured in this and really feeling that it is their story. Finally, using tech, so thinking about how do we integrate this kind of stuff on the ground with the kinds of amazing stuff that Rob and Nick and lots of other people are doing. And we have to do this, because what we have to do is think about, we can build the local buy-in. And we have this amazing global buy-in to the species, but how do we more effectively link up the two? As we're looking at novel financial mechanisms, so things like carbon credits you all have heard of moving. So this was a lion carbon credit, it's an additional premium one we were doing in Zambia with biocarbon partners to say how to get a premium credit for people living with lions. And now with various partners in Kenya and elsewhere, we're looking at developing a carnivore credit based a lot around the needs of local people. So how do you structure this? How do you think about which biodiversity needs to be represented? How do you monitor that, verify it? How do you make it equitable? There's a whole bunch of work around that. But I think it's going to be super important and exciting so we can translate that global value we recognise right down to the bottom level, right down to people living with them, and really ensure a much healthier coexistence going forwards. We know this stuff works. So in the core area, the carnivore attacks have reduced by over 60%. And importantly for us, the lion killings have gone down, the carnivore killings have reduced by over 80%. And the community conservation, if people ever think about community conservation, they tend to think of this kind of stuff, people working and talking with local communities. But as we showed right from the beginning, these are global assets. There is a global interest in big cats and other species. So how do we make the global community buy into this properly? And that takes all the kinds of things you're hearing about today. The tech that these guys have been talking about, I know Barbara's going to talk about how do you engage people locally to think about monitoring and buying into it. And then how do we bring those together to make sure that we've got the best tech and the best incentives so that we can deliver the best outcomes both for people and for wildlife on the ground. Thank you very much.
So, hello, I'm Barbara, and today I'll be talking to you about the Pembroke Biodiversity Project. So, as you look around this room, at board panels, the clothes that you're wearing, the chairs you're sitting on, hopefully you'll realise that in one way or another, all of this stuff has come from the natural world. And there are many ways for us to understand and quantify the natural world, but one that we have discussed a lot today, and which is very prominent, is, of course, biodiversity. And if any of you are biologists or have anything to do with biologists, you'll know that there's a lot of debate as to how best to measure biodiversity. But in general, it is essentially the variety of all life on Earth. So everything from genomes through to individual organisms, communities, and entire ecosystems. Now, biodiversity is absolutely crucial to us humans. Of course, it has intrinsic value. We're surrounded by it every day. It makes up all of our ecosystems. But it also provides ecosystem stability, which leads to ecosystem services, which are essentially all the benefits that humans gain from nature. So these can be things like pollination, food production, flood prevention, removing CO2 from the atmosphere, and many, many more. However, as we all know, biodiversity is currently in crisis. It's declining worldwide, and it's declining extremely rapidly. So currently an estimated 1 million or so species are threatened with extinction, and the vast majority of the Earth's surface and the oceans have been in some way affected by humans, most of it very severely. Which is why biodiversity conservation and protection is particularly important now in these rapidly changing times, and why local small-scale projects, which everyone can get involved in, are particularly important, building up connectivity between biodiversity hotspots and protected areas. So this is where the Pembroke Biodiversity Project comes in. So it's a student-led initiative focused here at Pembroke, and it's been running for about 2 years now. And it has 3 key aims. So the first is, of course, biodiversity enhancement. So we essentially want to build up and protect the biodiversity across all of Pembroke's land. And this involves biodiversity monitoring, so understanding what we actually have, because that's the only way we'll be able to protect it. And of course, creating new biodiversity, either by restoring habitats or creating new habitats. The second aim is student research and training. So we're trying to put a very big emphasis on getting students to build up their practical skills in the field, in biology, but also transferable skills such as project management, communications, outreach, that can be used anywhere, even if people don't go into biology in the future. And finally, our final aim is outreach, so getting as many people involved as possible, both in Pembroke and the wider Oxford community, and hopefully beyond as well. So where exactly do we work? So as I mentioned, we focus on all of Pembroke's land. That bluish pin is where we are right now. That red pin is our main site. So some of you will recognise, hopefully, the Pembroke Sports Ground. We're largely based in the 2 fields adjacent to the Pembroke Sports Ground, and you can see what they look like here. I should also mention the college has this year set up an orchard as well at the bottom of the sports ground, and this is a shot from tree planting that's been going on. So the team itself is mostly made up of students. The entire project is driven by students, mostly undergraduates. A lot of them are biologists, but we have many people from other subjects in humanities, physics, maths, and a lot of graduate students as well come in and help with our events. And in the 2 years that this project has been running, the team has been very, very busy. So here you can see some action shots of the stuff that people have been getting up to. And the work we've been doing so far has mostly focused on establishing a baseline of biodiversity, understanding what's already there. So as I said, we know how best to protect it. So we've been running regular BioBlitz surveys at the site, which is essentially a survey of everything, from plants and fungi to insects, mammals, birds, anything you can find. We've also been running mist netting and bird ringing, which has a purpose beyond just looking at cool birds up close. It's a way of tracking bird populations through time. And then we also have several ongoing projects such as mammal footprint tunnels, where we collect footprints to try and establish what small mammals are around, camera traps, bird feeders, and bird boxes. So these are just a couple of the species that we've managed to find on the sites so far. The flower in the middle is a great burnet. This is an indicator of lowland meadow. So the smaller field that you saw is almost a lowland meadow habitat, and we're trying to bring it up to be a full lowland meadow habitat, which is a priority habitat in the UK. It means it's quite rare and it's home to quite valuable species. These are also a couple of shots from our camera traps. So you can see we've got quite a variety of visitors, particularly nocturnal visitors. So we've got deer, we've got foxes, rabbits, a pheasant, a lot of different garden birds, and these two blobs you'll just have to kind of trust me that is a mouse and a rat. And of course we've got our birds, and hopefully you can tell from these photos why bird ringing sessions are particularly popular, despite birds having zero respect for human sleep schedules. So they're all looking very cute and innocent on this slide. They are less innocent when they are biting your fingers.
Super neat.
So besides our ongoing monitoring, we've also completed several one-off surveys. So we've taken part in the Conference of Colleges survey. This was a university-wide initiative with colleges monitoring their land use, tree growth, and diversity of earthworms, birds, and insects. There was also a baseline biodiversity survey completed by a couple of ecologists from the biology department. So that was Thomas Atkins and Bernard Lewis, for anyone who's familiar with them. And finally, the college also carried out an ecological audit. In terms of outreach, we've given several talks about the project. So we did a very similar talk to this actually at the FreeCR, which for those unfamiliar is joining in the JCR, MCR, and SCR to discuss people's research. And also the Leverhulme Centre, which is a conservation organisation based here in Oxford. And through those, we've managed to secure a very generous donation of £10,000 in funding for this project from Tim and Claire Dunn, who are Parish Pembroke alumni. So that's been a great help. And one of the most exciting things is this year we've had our first undergraduate and master's project completed on the site. So we had an undergraduate poster presentation based on plant data from our fields, and a master's presentation and project based on insect data. And we've also established a more of a national collaboration this year with IRIS, which is the Institute for Research in Schools. And its aim is to bring a chance to do real-life scientific research to school students, generally in the years 7 to 13. So that's been exciting. The project will launch in September, and schools across the country will be able to take part in biodiversity-related research. So that's all we've been doing so far, but of course this is a long-term project and we want it to leave a lasting legacy on Pembroke and be taken over by new generations of Pembrokians. Now, of course, myself and a large chunk of the team are graduating this year, but the project is in good hands and they've already got a lot of plans for what they want to do in the future. So we've got three main aims which align with, or rather three main themes for the future which align with our three main aims. The first, of course, biodiversity and research. So we'll continue monitoring to see how our various interventions are working and if they're successful. We hope to, as I said, enhance the biodiversity in the area, restoring habitats such as the lowland meadow and the riparian buffer in the larger field, as well as potentially creating new habitats like the orchard, which has taken over a piece of the sports field. And of course, we also want to encourage further student research because this is a resource for students largely. as well as the wider community. Theme 2 is refurbishment and development of a site. So some of you might recognise the sports building. It's a place of a lot of potential that isn't used to its full potential right now. So we're hoping to create a bit of space for the biodiversity project, a bit of a lab space, put more signage so both Pembrokans and the general public are more aware of what's going on. And then, of course, practical things like equipment storage. And finally, we really, really want to build up the outreach aspect. So this project will always have Pembroke at its core, but we do want to open it up to the wider university, the wider community in Oxford Town and beyond. So we've been focusing largely on Pembroke so far, but as I mentioned, we've also been working with the university to organise wider events, and particularly FIRUS, which means we're now going national. So the project is growing rapidly, and I hope that you can join us in this journey. Thank you.
So I hope that the four speakers, or the three speakers and myself, the research that we have outlined and some of the challenges that we have encountered will give you an idea of the things that Pembroke biology and Pembroke conservation biology have included in recent years. But now what I would like to do is to invite the speakers to the front line, and then I open the stage for Q&A. Perfect timing, Barbara, that worked. So any questions, we'll be happy to take in, and I'll ask the speakers to please repeat the question so that they can be taken on the in case the microphone is not working.
Thank you very much for very interesting talks. Perhaps a question about the robot, the walking robot. Well, gathering data under present. So, where are you in terms of advancement and the possibility of disseminating that? And is it still a pilot project, or do you think that this sort of data acquisition could be developed further and be of use for, I don't know, forest managers in private or public settings?
Yeah, absolutely. I'll just repeat the question. So the question was kind of, where are we at with the forest kind of measurement project, and where's it going next, supposedly? So this is a project, it's driven by a European project called DigiForest, which Oxford is a part of, and that's being led by my colleague Maurice Fallon. Within that, they've actually developed a handheld device that can be carried. So the robotic part is, for me, the fun bit, and that allows us to effectively, we'd like to have resident robots that live in forests doing this monitoring, because if you do it with a robot, you tend to get higher repeatability and accuracy. But the device itself is quite mature, and it's let's say the actual device is being used for also mapping construction sites and nuclear decommissioning environments and things like that. The forest has kind of been an interesting byproduct. They have quite mature algorithms now for recognizing trees and doing the measurements, so the DPH measurements. And that is being driven directly in that project into sustainable forestry, so into kind of companies that are monitoring forest lands. So I think that's reasonably mature, and that there is quite a lot of excitement around using it in these use cases. I think there's a bunch of open challenges. So I think for forestry, I think it's quite, I wouldn't say it's ready, but it's mature. When we're looking at kind of biodiversity assessment, it's really capturing one element of that forest. So the trees are very visible in the LiDAR. Saplings are not. The canopies are not visible. So there's a much bigger story that needs a lot of work to integrate other types of sensing, other types of measurements as well.
I have a question for Amy. Amy, thank you, first of all. They're really interesting, all talks. Now, if you're successful, you are being more and more successful, that means the lion population is going to go up and up and up. So what is the strategy for that one? There must be a strategy for dealing with, I mean, we have the same levels. You know, you protect them, but the numbers go up and up and up, and the ecosystem doesn't expand.
Definitely. So the question, just to repeat it, was, what happens if we're being successful, if this becomes very successful, the lion populations grow, what happens then? And I think that is a real problem. We have quite small or fenced systems. We are very lucky where we are, particularly in southern Tanzania, that these are huge ecosystems. The Rungwe-Ruaha system is about 50,000 square kilometres. So it's absolutely vast, and it's the lion populations at the moment are well below carrying capacity. So there's a long way to go before it's going to be the level where it's over either ecological carrying capacity, but of course there's a social carrying capacity too. And that's why it's really important to make sure that when more lions are seen, that it gets more benefits locally, that lion presence is tied to community development, because otherwise, of course, conflict will go up, more depredations will happen, more attacks potentially on people happen, and nobody's going to want that. But I always think it's a little bit like cars, that if we all accept cars being around in our cities and everywhere, even though they kill people, because they benefit us individually and collectively. And so what we need to think about is how do you end up getting it to the state where wildlife presence, even though it has risks, that the benefits outweigh those and you choose to have it there. So I think that's why we're trying to build in both the conservation but also the social side as well.
And part of it, I guess, is to have the lands integrate. So you having a source.
Definitely. So
the wider ecosystem where you're not yet talking to people.
Yeah, exactly. So the question about the wider ecosystem and part of that being the solution, absolutely, where we are on village land, and if I had more time I would have gone into it, is right on the edge of a national park that is unfenced. And so these are kind of a spillover, almost a spillover population from that park. And so when they become more lions there, there's a lot of space in the park for them to be. And it's a huge park. So we don't have some of the problems that you see in some, but there's a genuine consideration in a lot of projects.
Please.
Yeah. And the other, obviously, a lion is a keystone predator. The other predators, leopards, tigers, not in Africa, but are you concerned about their population, Sue?
Yep, so just asking, is it just about lions? No, absolutely. We're called lion landscapes, but it's very much, it's about the main 5 large carnivores, so lion, leopard, cheetah, wild dog, spotted hyena, and also everything below that. You need the prey, you need the social conditions for them. So lots of what we do, it's why on the camera trapping, we didn't just give points for lions. So you have to give points for the prey, you have to give points for the primates that cause conflict, you have to give points for everything, the ground hornbills and things. So really important to think about how do you build systems where that whole ecosystem is valued, not just a particular type.
There was a question in the back.
Yeah, just a question for Barbara about whether other colleges who also given the land to rewilding, and whether you're working with those colleges and whether students from other colleges which don't have related land that be given over to these kind of projects that work in your Kaplan estates.
So as far as I'm aware, this is the only college-based project of this scale. I think one of the colleges gave us some land to Hogacre Common Eco Park, which is actually our neighbour down at the sports site. But I don't think the college runs that land anymore, so that's a community-type project. I know there's a bit of biodiversity work happening in other colleges just on their main site and any land that they have. We haven't started collaborating with them yet, but that's definitely something that we'd like to look into. There's actually a group been organised in Oxford, I think it's called the Gardens and Parks group, which is trying to bring together all these green spaces, and they've been in a couple of their meetings, so hopefully we can integrate a bit more into that. And in terms of people from other colleges coming in to our project, we've had quite a lot of engagement, especially with BioBlitzes and the misnetting, because we've been trying to advertise them more widely, especially through student societies. So we've got quite a few people coming in from outside Pembroke as well.
To Amy, I have a question for Nick and Amy, what's happening? Really inspiring. Was just wondering, because you're doing community benefits and everything, where does the funding come from for these benefits? Is it private? Is it public? Do we engage with the government? Or that seems to be a really most important part of it.
Definitely. So the question was, where does the funding come from the project? Hopefully this room, there'll be a collection box on the way out. So it comes from all sorts of different sources, everything from NGOs to things like, National Geographic, People's Trust for Endangered Species, lots of zoos have been big supporters of it. We're looking at things like Darwin grants. So there's a whole range of different funding sources, some individual philanthropists that have been very generous. So the project runs at about $1 million, just over $1 million, for about $1.2 million a year across the 3 countries. So it's high, and it's a bit terrifying each year to try to think of raising it. But on the other hand, I think it's because it's got so many different components of education and conservation and human development. It's got something for lots of people in it. In terms of the Tanzanian government, so the UK government does it, or Tanzanian or Kenyan give other support. But I don't think it's necessarily fair to be asking them. They give huge amounts of land. They are relatively much poorer than us. I think this needs to be thinking about the global community. How do we fund this and make it help drive development?
About the robotics. So you said like specifically.
So I'm just gonna we'll come to this. I've seen the other questions. We'll get to as well. Cool. Yeah. Sorry. But carry.
Yeah. So yeah, for saplings and other things.
Yep.
Yeah, it's hard. I get it. So where do you see the field is going to go? Is it about developing better LiDAR so that the beam evaluations are not the rest will be able to pick up tiny objects? Or do you think, yeah, like processing is where the challenge is?
I think it'll be more on the AI side, machine vision. So we've already got. Oh, sorry. So the question was. So I mentioned earlier that we're detecting. We'd like to detect smaller trees, saplings, other types of growth. What developments do we need for that? And I think the answer is probably better kind of AI methods for segmenting and identifying these things. So there's a huge amount of work on computer vision, and that work requires labeled data. It's very hard to get labeled data by just taking lots of pictures and asking people to kind of crowdsource the labels. A lot of what we see in kind of the robotic space is using something called self-supervision, where you can take one sensor modality and use it to train another. So if we can get some very high resolution, expensive LiDAR scans of a small area, get that labeled, then you can use that to create labels automatically for just sort of standard cameras or multispectral imaging and things like that. And then you can use the signals for that on a much larger scale. So I think it's really about having more people working in that space. So I think the kind of actual number of people working on applying these kind of methods to the biological sphere is very limited. What you're seeing now is actually because of the need to apply robotics to agriculture, there is a growing area of people working in kind of computer vision for various plant processes. And I think that will lead to an impact in the kind of biodiversity assessment as well. Cool. So there was a question at the back.
We slightly touched on what I was going to want to do because it was such a nice juxtaposition. You have these wonderful sexy cats and animals to the creature.
Yeah.
I was going to ask you about green blindness, actually.
Right.
And the fact that it's that. But is it harder to get people, customers, members more excited about small buttes in meadows than little stuff?
I'm going to pass that to Rob. Yeah.
I think it is undeniably more difficult.
Yeah.
Sorry. Good point. So the question is about plant blindness, which is a phenomenon whereby the general public tends to overlook the importance of plants for ecosystem services, and we tend to focus more on things that look more like you and I: 2 eyes, 4 limbs, mammals, birds. So I think that that's undeniably a fact that plant blindness is a thing. I'm telling you this as a plant ecologist, and I work with animals as well, but my actual background is in plant ecology, right? But I think that one thing that many of my colleagues and I would agree on is that it's not about conserving the lion. It's not about conserving the koala. It's not about conserving the rhino. It's about maybe using them as a flagship species to then preserve the entire ecosystem. If the funds come through preservation for the lions, that percolates not only into the full community, but also into the human community as well. So in terms of where the funds come through, I'm not particularly too picky, because funds are funds, but it's having that idea that species don't live in isolation, and if you preserve the lions, you're actually preserving the entire ecosystem.
I don't know if that answers the question. To be like, that doesn't necessarily help, does it? I mean, so should you be winning funding for Amy?
Yes.
That's what I'm hearing. You're going, I don't care. But you need this dedicated effort.
You really do. But I guess what I'm trying to do is be a bit more down to earth and be a bit more realistic, right? So this plant blindness is perhaps a battle that it's going to be really difficult to fight against. And it breaks my heart to admit to that, by the way, as a plant ecologist, right? I continue to write proposals with Nick and other folks where we develop projects to evaluate forest dynamics, completely ignoring animals, by the way. And sometimes we're lucky, sometimes we're not. But I think that we ought to be very holistic in our approach and understand that when you're actually preserving the cheetahs of the world, you're actually preserving the entire ecosystem.
I think there is also, it's difficult for people to assume that the sexy mammals, yes, it's easier to get funding than it is for a pond snail or something. But on the other hand, it can go, that in itself can harm even things like lion conservation. We don't want it just to be about the lions. We want it to be about how do you manage these animals that have very difficult decisions about how to weigh up their needs with human needs and ecosystem needs. And if people are just focused on certain charismatic species, you lose the ecosystem, you lose all these other things.
Yeah.
We all need to be better at trying to get people to think more holistically, and it is hard. It's a real challenge.
It really is, and I take it upon my own personal responsibility whenever I'm doing fieldwork in the Karoo Desert in northern South Africa, or in Utah, or in the Simpson Desert in Australia. and somebody stops by, a member of the general public, and they ask me, what are you doing there? I take it upon my own responsibility to actually, at the risk of collecting less data, stop all activities and explain to them and engage with them and tell them in as plain a language as possible why the research that we're doing is important, right? So in my lab, we work with mistletoes. Ask me about why they're important later beyond getting kissed under them. We work with carnivorous plant species. We effectively work with the lines of the plant, by the way. So it's there's a strong responsibility for researchers, for academics, not only to focus on making discoveries, but also to engage with the general public. And my hope is that out of this conversation, you'll be perhaps a bit more informed on the whys and the hows of what we do.
So I think it's interesting to go back to the Biodiversity Project, because over the last couple of years, you look at the impacts of, say, flooding in the UK. I think there's a much stronger awareness in the UK now of biodiversity and land use and how that's impacting the kind of ecosystem services. And I wonder if actually through our own local biodiversity efforts, that's going to help us understand it's not just lions. I don't know. Like, do you see a wider...
It's becoming a bit anti-lion.
No, sorry, we love lions.
I didn't sign up for this.
I don't know if there's...
It's also the leopards.
I think I'd agree, particularly because especially when we're doing bio-blitzes and trying to get people to engage with nature and wildlife, naturally the things that are easiest to engage with are going to be the plants, because they're just everywhere. So if you do a bio-blitz, you're going to end up looking at plants and probably insects. Whereas some of the more charismatic things, like mammals in the UK, in the day, you might see a squirrel, but it's not going to give you a mammal list. You want to focus on that. So I think getting people involved in this sort of thing definitely builds an appreciation for the species to
There was a question at the back first, and then we'll come to the front.
Yeah, and so on the Biodiversity Project, it's really rare to see things happening in Pembroke. It's obviously, being seen well, you've got more shooting links. Is there anything you're worried about there? Like on there, what are any kind of particular threats that area faces?
So the question was, are we worried about anything? But are there any threats to the area we're working on in the biodiversity project? So the smaller field, which is almost lowland meadow, and the main worry we have with that one at the moment is that it's going to be part of it, not the whole thing, but part of it is going to be used as a free route for the flood mitigation project, which is happening in the area. So we will get it back, but probably after a couple of years. But there's definitely potential there to rebuild the lowland meadow. Hopefully, that's kind of the thing that we're concerned about. The other field, though, isn't being touched, so we can do basically whatever we want with that field. And there's quite a lot of biodiversity on there already. So I think the main thing that we're going to focus on is making sure this project actually has a long-term reach, because it's a student-led project. There's quite a high turnover of students, of course, so you're going to have to find a new leader every couple of years at least. But we've got a strong team right now, and hopefully that will continue into the future.
So we're going to take one final question from you, Leslie, and then whoever has to answer that will answer that. And I'll encourage the rest of the audience to continue to ask questions after the session. Leslie, please.
I think I can possibly deflect it. It seems like your project and your project are in direct conflict in the sense that what you're doing is producing a machine that's going to do something, whereas you're actually trying to get people themselves to actually understand what the what biodiversity is and what it could look like. Also in Africa too. Is there somewhere we can use pay people properly to do this research, rather than go and or combine that with the sort of AI use of the...
Maybe I'll take that first and then hand it off, because I think my answer is quite quick. So the question was, is there a conflict between using technology and kind of educating and training and paying people to do this work? So I think most of the people that do robotics and AI in this university see it as a way of scaling human capability, not replacing human capability. So the world is very large. The amount of things we need to measure in the natural world and the amount of work we need to do, whether it's in agriculture or nuclear decommissioning, is far outstrips the amount of human labor we have available. And so robotics are a way of scaling what you can do using the same amount of human ingenuity and capability to do more and have more good. So it may be that the humans do different things, but the humans will always be part of that. And we just see the technology as a way of scaling up their capabilities.
Barbara, would you like to add?
Yes, so I would agree. I think because we don't use like robots on our site, we do use various kinds of technologies. So I'm not sure how many of you have heard about iNaturalist, but it's a tool that we use a lot in our BioBlitzes. It's actually an AI-based tool where you submit photos or recordings, and it automatically tries to identify what it is you're looking at. And that's been incredibly useful, especially in getting people who've never done anything to do with biology before to actually engage with what they're seeing. Because, as I said, we focus on plants and insects, both of which are notoriously difficult to identify out in the field. And just adding as well, I think it'd be really exciting to see the growth of technology, but there's always going to be a human who's having to develop that. You can't just send out a robot into the field with no prior data or someone going through it and expect it to know what it's meant to do.
Yeah, and I think just to answer the African side of it, I think it's always going to be important to have local people employed. We have, over 100 local people employed to do on-the-ground tracking and these sorts of things, and they use the tools. Again, it's a combined approach, saying how can you bring the best of both the people and the biodiversity, but also I think we for too long thought if you just provide low-paid jobs, and they tend to be low-paid because the skills tend to be quite easily found often, then that'll be enough and that'll encourage people to do conservation. It's nowhere near enough. And so I think the next stage we need to take is how do we blend that passion, global and local, for biodiversity, and how do we blend these high-tech things and come up ideally with the novel financial solutions, those long-term systems where you're not just relying on somebody being paid $10 a day, you're relying on somebody saying, this is a really valuable, biodiversity is valuable to us in all those really material ways, and that will incentivize, I think, long-term conservation.
Yeah. For me, I definitely agree with everything that has been said before. It's not either or, it's the complementarity, and it's finding where that bottleneck in the monitoring is and how we can use humans and technology to widen it. In terms of the outreach, this is a great way to engage with the younger generations and to allow them to put away their smartphone technology. We just last week took students who were visiting the university from Polynesia out to White Woods to show them how to use these small drones to collect information about the grasslands that we were talking about before. So I think it adds on to the portfolio of things that we can now use rather than shifts the agenda onto only technology.
I think maybe the thing that I've always impressed with Amy's work is also that final piece of actually we're dominated by markets and finance, and we have to find, and that's another part of the human way of dealing with things. It's not just paying people. We have to find a way of bringing conservation, biodiversity, social good effectively. We have to find ways of bringing it into a marketplace, which is, I think it's alien to a lot of us, but that is the way to make some of the transition sustainable.
Very good. I know there's more questions, but I need to bring this now to a close. I'd like to start by thanking all of you for attending, and also all the fantastic speakers. Thank you, Nick. Thank you, Amy. Thank you, Barbara. And if you have got more questions, please stick around and ask them. Thank you so much.